What's the guys? It's Simon. Today's videos on AQA Level Chemistry Paper 3, 2018. Question 1. Explain why the use of large excess of H2O2 and I minus means that a rate of reaction at fixed temperature depends only on the concentration of H plus. Well, the idea that H2O2 and I minus concentration is effectively constant, so have a constant effect on the rate and zero order, because they're so much significantly larger than H plus, large excess of H2O2 minus. Samples are removed at time intervals titrated with alkali. Still will explain what must be done to each sample before titrated alkali. Stop the reaction by dilution. Explain how the graph shows that the order with respect to concentration with respect to H plus aqueous is 0. First mark you say for just saying constant gradient, which is obviously true, as concentration of H plus changes / decreases. Constant gradient as it changes. Use a graph in Figure 1 to calculate the value of K1. What's K1? Well, it says here, what is that? And K1 is the rate divided by concentration of H plus ions. Okay, so use the graph to calculate the value of K1. So first thing I need to find out, really, is because large X is used so that K can be spread to this. I know that's a straight line graph, so therefore K1 is just going to be the gradient. So if I find out the gradient, then I'm already in a good situation. So if I just find out the gradient, let's just do that in here. So 40, 60, 80, 50, 420, 420, 440, 460, 480, 440, 0, 0.5 over x2 minus x1. Well, what's the x-axis? That's the x-axis, that's the y-axis. So y2 minus y1, 0.5 minus 0 over x2 minus x1 for 4. No, it's not 4. It's 410, 420, 430. Wait, I forgot. I can just completely just do this instead of having to look around. So it is for 10, for 20, for 30, for 40, for 50. So it's going to be 4. It looks like 415. So let's say 415. So 415 minus 0. So 0.5 divided by 415. I get 1.2 times by 10 to the power minus 3. 1.2 times by 10 to the power minus 3. Then it says give the units. Well, this is a tricky part, right? Well, what is this? It's rate, right? Concentration of this and time. So what's the units for rate? Moles per dm minus cube s to the power minus 1. S to the power minus 1. There you go. 1.5, plot these results in the grid. First three have been plotted. You just plot it. So I'm just gonna copy from what the Mark scheme's doing here. Obviously definitely not accurate, but yeah, it's just simple plot. Then it says draw a line of best fit. A key thing about this line of best fit is obviously it's going to be like this. And it's going to be a curved line of best fit, like that. Smooth curve. So let's write it out. Smooth curve line of best fit. Best fit. Then it says calculate the rate of reaction when concentration H plus is 0.35. Show you working with suitable construction in graph figure 2. Calculate the rate of reaction when concentration H plus is 0.35. 0.35, I go here, right? Alright, okay, I want to calculate the rate, then I'll draw a tangent here to curve here, and then I'll just draw like a big triangle and then just work it out from there. So it's probably going to be something, then you just do calculate your gradient. 4.09 times by 10 to the power minus 4. I guess this part is a bit weird. Just go to 0.25, then draw a tangent, and then yeah. 1.8, a general reaction for equation shown. Aqueous solution that all colorless but E is dark blue. A region is available that reacts rapidly with E. This means that if a small amount of X is included in the initial reaction mixture, it will react with any E produced until all of the X has been used up. Explaining given brief experimental details how you could use a series of experiments to determine the order of reaction with respect to A. Again, paper 3, practical, right? Stage 1, preparation. Measure suitable volumes of reagents. Measure known amount of X. Use a colorimeter into separate container. Stage 2, procedure. Start timer at point of mixing. Time recorded for appearance of blue color. Use of same concentration of B and C. Same temperature. Repeat with different concentrations of A. Stage 3, use of results. Well, 1 over time is a measure of time. Is a measure of time. Plot 1 over time against concentration of A, and then interpret the order from the shape, and then you get that part. Then interpreting order from shape of graph. Question 2. Elements in period 3 all react with oxygen form oxides. Given the equation, 2 observation reaction that occurs when sodium is heated in oxygen. Sodium and oxygen. Sodium solid plus O2 gaseous to form, well, what do I form? Excuse me. form, we look back in the period 3 elements and oxides. Sodium and oxygen, 2 sodium plus a half oxygen to form Na2O solid. Then the observations. Observation 1, observation 2. The orange flame white solid. Given equation and observation when phosphorus heated oxygen. Now this is a classic equation that they always love to ask, so if any I would memorize definitely this one. The observation white flame 2.3, the melting points are the highest oxides are shown. Explain the increase in melting point from sodium oxide to magnesium oxide. Okay, maybe a tricky question, but the idea that greater charge density on the Mg2 plus ion, therefore stronger attraction between Mg2 plus and the O2 minus, because remember these are oxides, or you could just say stronger ionic bonding. Explain why the melting point of oxide of silicon is much higher than that in the oxide of phosphorus. Now silicon, now if it was sulfur I would talk about the increased electrons, so stronger van der Waals. But since it's silicon, you should know silicon has a giant covalent structure, or structure slash macromolecular. So what does that mean? Well, then I'll say P4O10 is a simple molecular, and then I say covalent bonds between silicon dioxide much stronger than the intermolecular forces in P4O10. Question 245. Describe a method for determining the melting point of a sample. Sample was prepared in a laboratory. State how the result used to evaluate its purity. Place sample in suitable melting point apparatus. Use a capillary tube. Heat gradually to establish melting point range. If it's got a lower melting point slash broad range of melting points, indicates presence of impurities. And then if it multiplies agrees close to data book value, moves sharply over narrow range, indicates purity. It says calculate the percentage yield of cyclohexene. Okay, not that many questions left. So calculate the percentage yield of cyclohexene and then collect this much of cyclohexene. So the actual yield is 5.97 of the theoretical yield. Well, cyclohexene Cyclohexene can be prepared by dehydration of cyclohexanol using concentrated phosphoric acid. You should prepare this by placing this much cyclohexanol. Okay, so already I can see I'm going to have to use density is mass over volume. Therefore, mass is density times by volume, which is 0.96 times by 10, which is 9.6. Now that's the mass. Now we need to find out the moles of cyclohexanol. Hexanol, which is the mass, 9.6 over the MR of cyclohexanol. Which is what? Well, cyclohexanol and cyclohexane, and you got your OH, so it's going to be, per my calculator, so 12 times by 6 plus 12 plus 16 plus 1. And minus 1. So it's going to be 100. So that over 100. That will give you the moles of cyclohexanol. 1 to 1 molar ratio. That will give you the moles of cyclohexene. Then use moles in mass of MR to find out the mass of cyclohexene. You need to find out the MR cyclohexene. And then once you've got that mass, 7.87, 5.97 over 7.87, I want it as a percentage, times by 100, 76%. Like, these percentage yield questions are very, very, very similar. It's the same process every time. Density, mass, of volume, find out the mass, find out the moles, 1 to 1 molar ratio. That, then you can find out the mass of that using the MR. And the hardest part generally for me is finding out the MRs of these compounds that they don't give you. Sometimes they do. Describe a test tube reaction to show that the cyclohexanol had been dehydrated. Now this one's really tricky because you think about it, cyclohexanol to be dehydrated. What could a test tube reaction possibly be? Well, what have I gone from? I've gone from an alcohol to alkene. And what is one thing an alkene has that an alcohol doesn't have? A double bond. What's the test for a double bond? Bromine water. And you need to be able to spot that. So add bromine water, solution D. It would turn from orange to colorless / decolorizes. Suggest why sodium carbonate solution was used to wash distillates. The sodium carbonate solution would neutralize the phosphoric acid. Explain why it is important to open the tap of separating funnel periodically. The idea of the pressure buildup. Avoid pressure build up, or / release pressure, release the carbon dioxide. Give a property of anhydrous calcium chloride other than its ability to absorb water that makes it suitable as a drying agent in this preparation. Other than its ability to absorb water. That's the one I was going to say. Other than that, well, it does not react with cyclohexene. Does not react with the cyclohexene. Describe apparatus used to remove the drying agent by filtration under reduced pressure. So, remove the drying agent by filtration under reduced pressure. So you need the book of funnel. That's the description of words. Book not funnel and containing filter paper book not flash side on flash connected to vacuum pump. I think they can't just ask you to describe the apparatus, they also have to say description of words aloud as well, because in the textbooks it only has description of words, I'm pretty sure. I can't go through this one. Alright, let's just go through it. Why is cyclohexene short retention of cyclohexanol? Let's say use the model scheme. Cyclohexene is less polar than cyclohexanol. Less polar cyclohexanol. Therefore cyclohexene has a greater affinity / attraction for the mobile phase. This grade explain how an infrared spectrum would confirm that the cyclohexene obtained did not contain any cyclohexanol. The idea that there would be no additional peaks in the fingerprint region. Okay. Question 4.1, plot a graph of temperature against time. The opposite, use a graph to find temperature rise. And okay, so once you now I'm going to go for 4.2 first. Uncertainty was 0.1. Calculate uncertainty for the temperature rise. Oh, I can't do it anyway because I need to do 4.1 anyway first. So in order to find temperature rise, it's a practical skill again. How do you do it? So first thing you plot it, right? Then what happens, you plot all the points correctly. You draw two lines of best fits. 0 to 3 minutes, 6 to 12 minutes, and then extrapolate both lines to the 4th minute and you get 2.1 degrees Celsius. I'm not going to plot all of that, and that will take at least probably 5 minutes for me to do all that. Just a waste of time. So 0.1 over 2.1. But because the temperature change, I need to times that by 2. Times by 100. 9.5%. That's the trick. Suggested change experiment that would minimize heat loss. Use a lid. Use a lid. 4.4. Suggest and explain another change to experiment that would decrease the percentage of uncertainty. Uses the same thermometer. Increase the size of temperature change by increasing the concentration of acid/alkali. 4.5. Give an equation for reaction between ethylene dioic acid and potassium hydroxide solution. So it says ethylene dioic acid, it gives me the formula HOOCCOOH plus potassium hydroxide, short note KOH. Now what happens? Well, ethylene dioic acid, it's carboxylic acid, plus potassium hydroxide. You're going to form, well, carboxylic acid plus potassium hydroxide. So what you're going to form now is you're going to form K2OOCCOO CCOO plus 2H12, and you need a 2 here. Then it says You calculate enthalpy change per mole of water from this reaction. So first thing I would um, do is Q equals mc delta T, right? What is that? What does that mean? Well, M is the mass of water, right? Of water, and it says assume density of reaction mixture 1 gram per centimeter cube. Perfect. 25 centimeters cube of this, 75 centimeters cube of this. So Q equals 75 plus 25, 100, 100 grams times by 4.18. Oh, this is the first time I've ever seen that happen. It's usually always 4.18, but in this case it's 4.2. I don't know why they've done that, but yeah, that's unusual. So I guess you do need to read the question. You can't just assume it's always 4.18. Okay, times by temperature change. Well, temperature increased by 3.2 degrees Celsius, so that's the temperature change, 3.2 degrees Celsius. Then you get Q. Then I need to find out the moles, right? Moles is mass of MR. Or am I going to use moles concentration volume? I'm trying to find the enthalpy change per mole of water from this reaction, and so what I'm going to need to do is firstly find out the moles of the ethanoic acid, then find out the moles of potassium hydroxide, and then I can get the moles of. Okay, so that's what I need to do first. Because this one's a bit of a weird one. Usually it's always moles of mass of MR, but in this case moles concentration volume. So I'm going to have to do moles is concentration volume, which is 25 divided by 1000 times by 0.80. And that's obviously ethanoic acid. Then I'm going to use moles concentration volume to find out the moles of the potassium hydroxide, 75 divided by 1000 times by 0.60. And which one is with the water? It's the moles of ethanoic acid, and that's a 1 to 2 mole ratio. So I get the moles of ethanoic acid as 0.020. So now I just times that by 2, so I get 0.040 moles. Am I done? No. Delta H, and you also need to recall this formula. Delta H is Q divided by moles. I've got the moles, 0.040. I've got Q, right? That's Q. But remember, Q is measured in joules. I want enthalpy change in kilojoules multiplied minus 1. So whatever I get as Q, I need to divide by 1000. So 100 times by 4.1, is 4.2, yeah, times by 3.2. Then I need to divide by 1000, and then I do my answer divided by 0.040, and then I get 33.6. But I'm still not done yet, because I know what happens to temperature. Temperature increase. So what does that tell me about the reaction? It's got to be negative. Temperature increased. I'm going to say temp increased. Therefore, exothermic. Just these little tricks. And it's for 5 marks. So yeah. Now 4.6, in a similar experiment to that in question 4.5, the enthalpy of neutralization for the reaction between sulfuric acid and potassium hydroxide solution was found to be minus 57. I got minus 33.6. Oh no, suggestion, an explanation for the difference between this value and the answer to question 4.5. Sulfuric acid, what's sulfuric acid? That's a strong acid. Strong acid, right? And I was working with ethane dioic acid. So I would say HOOC COOH is a weak acid. More energy needed to break bonds. And bond dissociation is endothermic, hence my answer is less exothermic than then the answer given, 4.6. And that makes sense. HCO is a weak acid. Therefore, more energy is needed to break the bonds. What's bond breaking? Endothermic. Therefore, my answer is less exothermic. Therefore, it's being added a bit. So it's minus 33.6 when it should be minus 57.0. That is the end of section A.